Alright, so in class we really completed all of the new stuff in this set of notes. And as you've noticed, we pretty much go through the exact same steps for hypothesis testing as confidence intervals as we have for pretty much the entire semester. One of the places we seem to struggle the most, though, in this set of notes is on the interpretation. And usually actually here we have a harder time with the confidence interval interpretation than the hypothesis testing one. So we're going to focus on the confidence interval one first, but then we'll talk about kind of why the hypothesis testing one isn't quite as bad. So when we talk about confidence intervals, and our setup is to determine the mean difference in exam scores from exam 2 to exam 3, is what I'm going to use in this example. So we could get one of the following three scenarios to happen when I construct my confidence interval. Whenever I construct a confidence interval, I'm going to get a lower limit, and then I'm going to get an upper limit. Like, right, I'm going to get this range from between this number and between this number. So this is my between my lower and my upper. What I could have happen is my lower value could be negative, and my upper value could be negative. I could get a lower value that is negative, and an upper value that is actually positive. Or I could get my lower value to be positive and my upper value to also be positive. So we're going to go through each of these three scenarios for our example, looking at compare the mean difference in exam scores from exam 2 to exam 3. And for this, we're going to have my order of subtraction that I'm doing is exam 2 minus exam 3. So already kind of thinking about this on the side, right, so if I get a positive number, that tells me that exam 2 was higher than exam 3. If I get a negative number, that tells me that exam 2 was smaller than exam 3. And 0 would tell me that the exams were the same. So in our first situation here, what you'll notice is my lower limit is negative, and my upper limit is negative. Now if I go over here and look at what does negative numbers tell me, it tells me that exam 2 is smaller than exam 3. So that's how I'm going to want to interpret this. So each of our interpretations starts the same. Right, so here's my confidence level I did for it, is just that 95%. So I'm going to be able to say that I am 95% confident that the mean exam 2 score, because that's what I started with, my first thing I have listed here, is between, I'm going to pause there for a moment. I'm going to be able to say that it's lower than the mean exam 3 score. Now why am I saying it's lower? Well, both of my numbers are negative. Negative tells me that exam 2 is lower than exam 3. That's where that first part's coming from. Now then actual numbers, I've taken care of the negative, right? The lower is all that means for the negative. So now I can pretend that the negative numbers aren't even there. And I'm just going to put the numbers, and it makes more sense to put the smaller number first. So I'm actually going to start with the 1.08. So it's between 1.08 points and 8.92 points lower. So now I'm not only telling you that the average exam 2 score is lower, I'm telling you how much lower. So that's how we would interpret an interval that has a negative lower limit and a negative upper limit. The negative we take care of with the word and the interpretation that we use here. Once we take care of that part of the negative, we don't have to worry about it in the numbers up here. Now the second situation that could happen is you go from a negative number to a positive number. And actually out of all the interpretations, this one's the hardest. Why? because a negative number tells me one thing and a positive number tells me another. And so this is probably the weirder interpretation. So we are going to start the same way. So I am 95% confident that the mean exam 2 score is between, this is one that feels weird. So let's start with that negative 0.592. The fact that it's negative tells me that the exam 2 score is lower, so it's between 5.92 points lower to, now this one is positive. A positive tells me that exam 2 is actually higher than exam 3, so to 1.92 points higher than the mean exam 3 score. So notice with this interval, it includes 0. Right? So if I go from a negative number to a positive number, I include 0. That's why I have it's between this much lower to this much higher. So like, right, it could be lower, it could be higher, it could be the same, since 0 is inside of that interval. Finally, we have one where we have positive and positive. Positive numbers tell us that exam 2 is higher than exam 3. So my interpretation here, again, would start the same. So I am 95% confident that the mean exam 2 score is higher than the mean exam 3 score. Alright, now I'm actually going to put the numbers in. So I'm 95% confident my mean exam 2 score is higher than the mean exam 3 score. But more specifically, it is between 2.08 and 9.92 points higher than the mean exam 3 score. So with this example, I gave you all 3 different options that could happen. A negative number to a negative number, a negative number to a positive number, and then a positive to a positive number. Again, those are usually harder. Usually what's not quite as hard is the hypothesis test. And so I did change wording to say hypothesis test there. So doing the hypothesis test is what that should say, and yours should say that now. And the main reason why hypothesis testing is a little bit interval is all we say is that, is it greater or is it not greater? Is it smaller than? I mean, we have the 3 different alternative hypotheses. Right, so our alternative hypothesis could have a greater than. The alternative hypothesis could have a less than. And then the alternative hypothesis could have a not equal to. Those are our 3 options. And so when we have the greater than, our interpretation always will start at wherever our alpha level is. There either is or isn't statistically significant evidence to support that the mean, whatever we're talking about, is higher for this group then for that group. So I mean, for our example, I might say there is evidence to support that the mean exam score is higher for exam 2 than for exam 3. Or I might say there is not evidence to support that the mean exam score is higher for exam 2 than for exam 3. So I mean, there's not a huge difference in interpretation there. Very similar if I have the less than, my part is going to start the same. Again, depending upon if I reject or not, I'm either going to say there is or is not are statistically significant evidence. To support that the mean, whatever we're talking about, so again, maybe exam score, is lower for one group than for another. So maybe I'll say there at the alpha equals 0.05 level, there is statistically significant evidence to support that the mean exam score is lower for exam 2 than for exam 3. And that's what that's going to look like. Now, with that not equal to, it does depend upon if we reject or not. So, if we reject the null, the first thing I have to decide is the direction. Remember, anytime that we have that not equal to and we reject, so like, okay, this is different, we want to know how is it different. So, ooh, the mean exam 2 score is different than the mean exam 3 score. Okay, well, which one's higher? So we got to first figure out the direction that we get. Once we have that, it's going to look very similar. So at our alpha equals whatever level, since we would have actually rejected here, I'm actually going to put that there is the statistically significant evidence. To support there is our evidence to support that the mean, whatever we're talking about, is, and I have to decide, okay, is it lower or is it higher based upon, remember, deciding that direction for this group than for that group. Now, the other option that could happen right when we do that not equal to is we don't reject. So then our interpretation is going to look a little bit different. So this time again, it'll start the same. And since we're not rejecting, we would say that there is not our statistically significant evidence. To support that the mean, again, whatever we're talking about, is different. Remember, because we're just doing that not equal to for blank than for blank. So we might say at our alpha equals 0.05 level, there is not statistically significant evidence for that the mean exam score is different for exam 2 than for exam 3. So the interpretation here is just usually a little bit easier because we're not saying by how much, we're just saying, okay, either this is higher or this isn't higher. This is lower or this isn't lower. Or this is different and how, or this isn't different. So it's a little bit easier to do those interpretations. So next time we'll do another example before taking your quiz, but feel free to come prepared with any other questions you might have.